Everyone and welcome back to the series of digital logic design. Today we will study cases of a three variable kmap. Sometimes in a three variable kmap, two squares are considered to be adjacent even though they do not touch each other. Like in the given figure, if you consider m0 and m2, and we have another pair of m4 and m6. These both pair are considered to be adjacent though they directly do not touch each other. If we look at the definition of adjacent map, this says that every two squares are considered to be adjacent if there is a difference of one variable or of one bit. Now among these both pair, the difference is of one bit or of one variable, and this can be verified algebraically. Now if we add m0 and m2 corresponding to these, we will have minterms of x prime y prime z prime plus x prime y z prime. Taking x prime z prime common, we will be left with y prime plus y. So the sum of both terms will be simplified into x prime z prime and the dissimilar variable will be removed. Similarly is for m4 plus m6. Adding these two minterms, we will get the term of x dot z prime and the dissimilar variable y is again removed. So we can modify the definition of adjacent square to include this and other similar cases. The kmap can also be considered as drawn on a surface in which right and left edges touch each other to form the adjacent squares. Now in the given example, simplify the given three variable Boolean function. At first, draw the map of three variables which will have 8 squares. Now place the minterms of the example in the given map. Like minterms will be placed at 0, 1, 1, 1, 0, 0, 1, 1, 0 and 1, 1, 1. The 4 adjacent squares marked with the 1 for each minterm. Now if you look at two adjacent squares combined in the third column and look for dissimilar variable, in this case is x. So adding both minterms will reduce to the literal term of y dot z because y and z both have a value of 1 and x is the dissimilar variable. Now the remaining two squares with minterms are also adjacent by the new definition. So these two squares will be combined to give a two literal term of x dot z prime. So the simplified function will become y dot z plus x dot z prime. Now in the another case, consider any combination of 4 adjacent square in a 3 variable map. Any such combination represents the logical sum of 4 minterms and results in an expression with only one literal. As an example, consider the logical sum of 4 adjacent minterms of 0, 2, 4 and 6. If you add these both minterms, the terms corresponding to these will be x prime y prime z prime plus x prime y z prime plus x y prime z prime and x y z prime. Adding these 4 minterms will be reduced into a single literal whose value is constant among these 4 minterms, and that is z prime. So we can say that the number of adjacent squares that may be combined must always represent a number that is a power of 2, such as 1, 2, 4 and 8. Also, the more adjacent squares combined in a group results in a product term with a few number of literal. Like if we have a 1 square term, this represents a 1 minterm with 3 literals. Or if we make a group of 2 adjacent square, the term will represent 2 literals. And if we make a group of 4 adjacent square, then the simplified term will consist of 1 literal. Or if we make a group of 8 adjacent squares or of entire kmap, then this will produce a function which will be always equal to 1. Now in the given example, simplify the Boolean function which have a minterms at 0, 2, 4, 5 and 6. At first, a 3-variable kmap is drawn and minterms are placed at the desired location. Then for simplification, we make group of adjacent squares which contains the minterms. We know that m0 is adjacent to m2 and similarly m4 is adjacent to m6. So the first group will consist of 4 minterms having m0, m2, m4 and m6. Now we are left with single minterm which is m5. So for this we will reuse minterm m6 to make a group of 2 adjacent squares. Now it is the most desirable condition to reuse a minterm because making a group of 2 adjacent squares will give a simplified term which will have 2 literals. Or if we don't make a group and use a single minterm, then this minterm will be represented by 3 literals. Now for simplification, we will analyze both group of adjacent squares, group 1 and group 2. In group 1, the variable x and y have a constant value of 1 and 0 and the value of variable z is changing from 0 to 1. So the term corresponding to the first group will be x dot y prime. Or if we analyze the group 2, the value of variable z is constant where the values of x and y variables are changing. So the term corresponding to second group will be z prime. And the overall simplified function will be x dot y prime plus z prime. Now another case is if a function is not expressed in the sum of minterm form. In such a case, yet it is possible to use the map to obtain minterms of the function and then to simplify the function into an expression with minimum number of terms. But however, it is necessary to make sure that the algebraic expression is in the sum of product form and each product term can be plotted in the map with 1, 2 or more squares and the minterms of the function are then directly read from the map. Now in the given example, you have to find minimum sum of product term expression for the Boolean function and the Boolean function is x prime z plus x prime y plus x y prime z and y dot z. Now if you analyze, the given function is a standard sum of product where and the given function consists of overall 3 variables x, y and z. The 3 product terms in the expression have 2 literals and the 1 product term have 3 literals. The term with 3 product terms is represented by 2 squares in the 3 variable kmap. Like if we analyze the first term which is x prime z. Now we know that if a minterm consists of a prime literal, this means that variable have a value of 0 and unprime literal is used, this means that variable have a value of 1. So we will introduce the missing variable with 2 possible combination that a variable may have a value of 0 or 1. In the first term, y is the missing variable, so we will introduce and the term will be x prime y z and the possible minterms will be 0, 0, 1 and 0, 1, 1. Similarly, in the second term, z is the missing variable, so we will introduce the missing variable with all the possible combination of values, that is 0 and 1. So the next minterm will be 0, 1, 0 and then 0, 1, 1. In the third term, we don't have any missing literal, so the minterm corresponding to the third term will be 1, 0, 1. And similarly, in the last term, x is the missing variable, so we will introduce the variable x in the term 4 with 2 possibilities that it may have a value of 0 or 1. So the minterms will be 0, 1, 1 and 1, 1, 1. Now we have all the possible minterms in the map, so we will combine them and will remove the repeated one. So the minterms are 1, 2, 3, 5 and 7. Now the given function can be expressed in the sum of minterm form. Now for simplification, we will make a 3-variable kmap and will place the minterms at 1, 2, 3, 5 and 7 and will make a group of adjacent squares. Now here we have two possibilities. First group will consist of 4 adjacent squares and a second group will consist of 2 adjacent squares. If we analyze the first group, this group have x and y with constant values and value of variable z is changing. So we will remove the dissimilar variable and this will result in a function f1 equals x prime y. Now if we analyze the second group, among all the 4 adjacent squares, the value of variable z is constant and have a value of 1. So the simplified function corresponding to second group will be f2 equals to z. Now the overall simplified function will be sum of f1 and f2 and will be equal to x prime y plus z. Thanks for watching the video and stay connected for more interesting videos.